Hello students, I am Ranjitha, working as a mathematics lecturer at Government Pre-University College, Hiriadka. I will take up mathematics for you. Today we will begin with the first concept, set theory. This set theory is developed by German mathematician George Cantor. In this topic, we are going to study many concepts. First, introduction to sets, sets and their representation, empty set, finite and infinite sets, equal sets, subsets, power set, universal set, Venn diagram, operations on sets, complement of a set, and finally, practical problems on union and intersection of sets. So what is a set? To know about this in detail, we'll consider few examples. We'll consider our day-to-day life examples like collection of animals, collection of vegetables. All these are familiar to you actually, you can list out, right? Collection of favorite sweets. Collection of odd natural numbers less than 10. Now, we have considered 4 examples here. Among these 4 examples, my question is whether all the examples form a set or not. Obviously, all the 4 examples does not form a set. So, how to check which one is a set and which one is not a set? For that, consider first this example itself. Consider this example. Collection of odd natural numbers less than 10. Under this, we can list 1, 3, 5, 7, 9. You know that set of natural numbers denoted by n and it consists of 1, 2, 3, like this it goes. But here it is collection of odd natural numbers, so that includes 1, 3, 5, 7, 9. Because it is given like collection of odd natural numbers less than 10. So we can list 1, 3, 5, 7 and 9. So here we can list the entries, right? So it is well defined. We can say that this form a set. Consider the previous example. Collection of favorite sweets. According to my point of view, my favorite sweets are jamun, coconut burfi, rasgulla. Suppose if you answer to this question, your answer may be different, right? So this collection is not well defined. Not well defined because the answer varies from person to person. It is not fixed, right? So this collection is not well defined. So this does not form a set. Consider one more example. Name the core subjects you have studied in 10th standard. So what are the subjects you have studied in 10th standard? Including language, science, mathematics, social science and languages. Suppose if we exclude language, then the core subjects are science, mathematics and social science. So this collection is well defined because if I answer to this question, my answer is same. If you answer to this question, your answer was also same. So the collection is well defined. This forms a set. Suppose if I change a little bit in the question itself, among these 3, suppose if I ask, name the subjects which is difficult to study. If I answer to this question, according to me, I feel social science a difficult one. Suppose if you answer to this question, then it may be different one, right? So here the collection is not well defined because the answer varies from person to person. Therefore, this does not form a set. So how to that answer may vary from some other person's point of view. So here answer varies from person to person, so it is not well defined. Consider fifth example, collection of students in a class whose marks is above 75%. So this we can list out, right? So target is 75%, so we can list the students who scored more than 75%. So this is well defined, so this forms a set. Consider last example, collection of beautiful girls of India. This also varies from person to person, so answer is not fixed at all, so this is not well defined, so this does not form a set. So we can conclude like any collection cannot be the set, a well defined collection of objects only forms a set, right? Now, come back to the notation. How to denote a set? How to denote a set? Usually, capital letters are used to denote a set. A, B, N, like this. So, we use capital letters to denote a set. And members of the set are called elements of the set and written within the braces. Elements of the set are written within the flower bracket. Suppose if we consider A is the set with elements A, B, C, then elements are written small letters now, but elements are separated by commas and written within the braces. Consider set B as 1, 4, 9, 10. Here set B contains 4 elements separated by commas and written within the braces. Consider set of natural numbers. You know that set of natural numbers starts from 1. So it includes 1, 2, 3, dash dash. Now, if you observe, here the set A consists of 3 elements. So number of elements in the set is called cardinal number of the set. Number of elements in the set is called cardinal number of the set. So this is called cardinality and denoted by N of A. Here set A consists of 3 elements. So N of A is cardinal number of A, that is 3. Consider B. Set B has 4 elements now. So cardinal number of B means N of B, that is 4. Set of natural numbers. Here we can list the elements, but it is not ended. So we cannot write the cardinality because it is infinite set. So we can conclude that a set is a well-defined collection of objects. Elements of a set are synonymous terms. Sets are usually denoted by capital letters. Elements of a set are represented by small letters. Elements of the set are represented by small letters. May not be the letters always. You can use numbers, you can use images also. We'll consider a few more examples. Name the whole numbers less than 5. Name the whole numbers less than 5. So, whole number is denoted by W. We have to consider whole numbers less than 5. So, the set includes 0, 1, 2, 3 and 4. So, cardinal number of W, N of W, that is 5. Cardinality of W is 5. Here, there is a usage of the symbol belongs to. So, this means belongs to. So, when to use this? Consider the example W equal to 0, 1, 2, 3, 4. So, if you observe 0 is an element, 1 is an element, 2 is an element of W, 3 is an element of W Now, why I consider these two examples? See here, set B has F, O, L, W, but the actual word has L repeated 2 times, O repeated 2 times. So we can conclude that while writing the elements of the set, repetition should not be allowed. Repetition should not be allowed. And order also, it is not important. Whatever may be the order, see here, set A has 4 elements, W, O, L, F. Set B also has 4 elements, W, O, L, F only, but in the different order. So while writing the elements, order is not important, and while writing the elements, keep it in mind, repetition should not be allowed. Is it clear to you? Okay, fine. Let's consider exercise 1.1 in that first question. Listen to me, students. I'll consider few questions to solve here. Whatever the questions I leave here, you have to solve that as homework. Okay? You have to write it in your notes also. Now consider exercise 1.1 in that first question. It's easy. Which of the following are sets? You have to justify your answer. First one, the collection of all months of the year beginning with the letter J. Now just think of the months of the year. How many you have? 12. So you have to list out the months starting with the letter J. So you can list January, you can list June, you can list July. Only this much, right? So cardinality of M is 3 now. That is not asked actually. You have to just list which examples form the set, which is not forming set. Okay. So first one, it is well-defined collection. This forms the set. Consider second one. The collection of 10 most talented writers of India. The collection of 10 most talented writers of India. So this varies from person to person, right? So this is not well-defined. So second one does not form the set. Consider third question. A team of 11 best cricket batsmen of the world. The team of 11 best cricket batsmen of the world. So this also varies from person to person, right? So this is not well defined. So third one does not form the set. Consider fourth one. The collection of all boys in your class. This we can list out easily. So this is well defined because if I answer to the question, it is same. If you answer to the question, that remains same because it is the list of boys in your class, right? So this is well defined. So fourth example form a set. there are two representations. One is roster form or tabular form. Another one is set builder form. So any set can be represented in two ways. One is roster method or tabular method. Another one is set builder method. Okay. So we'll consider first one. That is roster method. So what it says? See here. In roster form, all the elements of the set are listed. All the elements of the set are listed. The elements are being separated by commas and are enclosed within braces. Now listen to me. If we consider the collection of days of the week, collection of days of the week. Suppose if I denote the set as A, can we list the entries now? We can. So start from Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. So here cardinality, that is 7, right? You know that. Now, here the elements are listed, written within braces, separated by commas, right? So this representation is called roster form or tabular form. See, the name itself indicates it is tabular form. Under statistics, you may be knowing what is tabulation, right? So writing in the form of the table, so collecting all the entries, right? Here also similar to that only, all the elements are listed, written within the braces and separated by commas. Suppose if we consider one more example, set of natural numbers less than 5. Set of natural numbers is denoted by n. It is less than 5 means the set includes 1, 2, 3 and 4. So here the elements are listed 1, 2, 3, 4 separated by commas and written within the braces. So this form is called tabular form, means listing the elements of the set. Consider second form. This is set builder form or it is called rule method. Okay. So as the name itself indicates, the representation is in the form of rule. Rule means statement. So here what it says, in set builder form, all the elements of the set possesses a single common property. All the elements of the set possesses a single common property which is not possessed by an element outside the set. So the feature or the property is possessed by the elements of the sets only, not by the element outside the set. So this is what set builder form. I repeat, in set builder form, all the elements of the set possesses a single common property which is not possessed by an element outside the set. Let's consider one example. Consider n equal to, it is a set containing x such that, see here, this notation is used to represent such that, or you can write like this also. Okay, any notation can be used, but how to read this? Such that. So set n is a set check. Put n is equal to 1. So 1 square will get 1, right? Put n is equal to 2. 2 square will get 4. Put n is equal to 3. 3 square will get 9. Put n is equal to 4. We'll get 4 square, 16, right? So this representation is called set builder form. This representation is called roster form. So we can conclude that we can convert from roster form to set builder form, or we can convert from set builder form to roster form. Is it clear now? We'll consider more examples when I consider the exercise, okay? Consider exercise 1.1 only. Consider question number 3. Write the following sets in the roster form. Consider first one. A is equal to, set A is equal to, it is a set containing x such that x is an integer, and minus 3 less than or equal to x less than 7. So it is given in the, can you identify which form it is? It is given in the set builder form. You have to convert that to roster form. So use the same letter, that is A now. A consists of, it is integer starting from minus 3. So if we list out minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. Till how many? It should be less than 7. So 4, 5, 6. So this is in the roster form or tabular form. Consider second example. Set B is equal to, it is a set containing x such that x is a natural number less than 6. X is a natural number less than 6. So if we list out 1, 2, 3, 4, 5. It is less than 6, right? So 1, 2, 3, 4 and 5 only. Like this you can complete all other questions, okay? Now consider question number 4. Write the following sets in the set builder form. So you can observe, see the first question is 3, 6, 9, 12. Means it is in the roster form, right? It is in the tabular form. Now you have to convert that to set builder form. I'll consider the first question itself. I'll consider the first question now. 3, 6, 9 and 12. 3, 6, 9 and 12. Name is not given. You can give any name. So I'll consider it as set A. So set A is a set containing x such that, listen to me now. First entry is 3. Second entry is 6. There is a relation between 3 and 6. So 3 2s are 6. There is a relation between 3 and 9. 3 3s are 9 will get. There is a relation between 3 and 12. 3 4s are 12 will get. Now listen to me. This is 3 1s are 3. 3 2s are 6. 3 3s are 9. 3 4s are 12. So if you observe, it is the multiple of 3. So x is equal to 3n. So what about n now? N is set of natural numbers. N belongs to n only, but n is